All right, so today was an activity task involving conditional probability. So I'm going to start by having you fill out or draw this frequency table, and you're going to go ahead and use the data in this Excel sheet. So go ahead and pause the video while you copy this down, and then come back and hit play. And we're going to go ahead and get started from there. So right here, we read a two-way frequency table in a similar way as a regular frequency table. For example, the number of orange Skittles is listed where the orange and the Skittles row meet. This is called a joint frequency. We also can find the total number of blue candies in the bag. We just look at the total of the blue column. This is a marginal frequency. So it's important to understand the difference between a joint frequency and a marginal frequency. A joint frequency means you're looking for at least two characteristics. So in the example that it gives, we're looking for its orange and a Skittle. So we're looking for two different things. Versus a marginal frequency is just looking for one characteristic. So we're deciding if it's blue, which is just one characteristic, so that's a marginal frequency. So joint, two characteristics, marginal, one characteristic. So we're going to use the data that we got from this Excel sheet, and hopefully you filled out into a table, to answer some questions. So starting right here on analyzing the data. So we can compute the probability of an event occurring from the frequency counts within the candy mix two-way frequency table. Find the probability of randomly choosing a candy with the listed attributes. Also identify each event as either joint or marginal. A joint probability requires two or more characteristics to hold true, whereas a marginal probability requires only one. So I'm going to go ahead and go through the first two examples and then have you go through the rest. So the first example is any color of M&M. So the only thing I care about is that it's an M&M, which is just one characteristic. So that means that this is marginal, because marginal is just from one characteristic. So right here we'll say marginal. And then we've got to find the probability of drawing any M&M, so I don't care what the color is. So I'm going to come back to my frequency table, and I don't care what color M&M it is, I just care that it's an M&M. So I have 326 M&Ms, and I have 580 total bags. So I'm going to do 326 divided by 580 to find the probability of drawing an M&M. So I'm going to come here, and I have 326 divided by 580. So if I take a calculator and go ahead and divide that out, 326 divided by 580 is 0.56, which is 56%. So the probability of drawing any M&M is 56%. Then our next example is a purple Skittle. So that has two different characteristics. It's purple and it's a Skittle, which would make it a joint probability. So then we're going to go ahead and look at the probability of drawing a purple Skittle. So if we come back to our frequency table, how many purple Skittles do we have? So we're going to go to where it says purple Skittles. There's 43 purple Skittles. So 43 divided by our total of 580 is the probability of getting a purple Skittle. So I'm going to come back to here, and I have 43 divided by 580, and again I'm going to do that in my calculator. 43 divided by 580 equals 0.07, which is 7%. So using that exact same logic, pause the video and go ahead and try to find the rest of the probabilities that it asks for. When you get to the bottom, let me scroll down really quick. That asks you two questions. In your own words, describe how you compute a joint probability, and then in your own words, describe how you compute a marginal probability. So in order to do that, when we found any color of M&M, that was a marginal probability. So you're just going to describe how we found that marginal probability right here. And then finding the purple Skittle, we found a joint probability, so you're just going to describe how we found that joint probability here. And then when you finish that, come back to the video for the next page. The next page is finding conditional probability with counts. So it gives us a little situation. Imagine that your friend chooses a candy piece from the class mix. She looks at it, tells you that it is red, but doesn't tell you if it's an M&M or a Skittle? Knowing that your friend has a red candy in her hand, we can find the probability that it is a red M&M. This is called the conditional probability of an event because we already know something, a condition about the event in question. So we're going to look at the following questions. So we know, this little reminder, we know the candy is red. So we want to know the total number of possible outcomes for the candy when we know that it's red. So if we come back to our chart, we come over to the red column and we have 96 red candies. So that's the total number of outcomes is 96 because there's 96 possibilities for our red candy. So we're going to go ahead and write 96. Then the second question is the probability of having an M&M if we know the candy is red. So we only care about the red and the M&Ms that are red. So if we come back to our table, we already know we have 96 red candies. 46 of those red candies are M&Ms. So if I come back to here, I have 46 possibilities for 46 red M&Ms divided by 96 red candies. And again, I'm going to go ahead and use my calculator. 46 divided by 96 is 48%. So there's a 48% chance that your friend has an M&M, assuming that her candy is red, given that her candy is red. So in your own words, explain how to compute conditional probabilities given a two-way frequency table. So this is a conditional probability. So go ahead and in your own words, describe how we computed that in the space right here. And you can go ahead and pause the video if you need a second to do that and then hit play. The last sentence on this page says, what you just found can be written as P probability of an M&M given that it is red. So that's how this is read, the probability of a candy being an M&M given that it is red, when we know that it is red. So we're going to go ahead and find several conditional probabilities on the next page. So we're still using the same data table, and we're going to find, I'm going to show you a couple of examples, these first two examples, and then have you try the rest. So we're finding the probability that a candy is green given that it is a Skittle. So we know that it's a Skittle, which means we don't care about the M&Ms. We know that it's a Skittle. So we're going to go look at our table and see how many Skittles we have. We have 254 Skittles. So if I come back to here, I know that I have 254 Skittles. Now I want to know the probability that it's green since I know that it's a Skittle. So again, I'm still ignoring the M&Ms because I know it's not an M&M, so that doesn't matter, but I don't know what color it is, and I want to know the probability that it's green. So if I look here, I have 66 green Skittles. So coming back, I have 254 total Skittles. I have 64 green Skittles. So the probability that it's green, if I know that it's a Skittle, is 64 divided by 254. So again, using my calculator, I have 64 divided by 254, which is 25%. The next one is a similar idea. So I know the candy is blue. So I don't care about red or green or brown or purple. I only care about the blues because I know that the candy is blue. So let's see how many blue candies we have. We have 80 blue candies. So I'm going to come back to here and write that down. Okay, I have 80 blue candies. Now, I only care about blue candies, and then now I want to know how many of my M&Ms are blue. So I don't care about any other colors. Let's figure out how many blue M&Ms I have. So coming back to my table, I have 80 blue M&Ms because there's no blue Skittles. So 80 blue M&Ms. So I have 80 blue M&Ms. So to find the probability that it's an M&M, if we know that it's blue, is 80 divided by 80, which is 100%, which makes sense, right? Because if we go back and look at this table one more time, and I'll erase this. If we know that it's blue, it has to be an M&M because there's no blue Skittles. So if we know that it's blue, we also know it has to be an M&M. So there's a 100% chance that it's an M&M if it is blue. So I'm going to let you try the rest of these. So try finding the rest of these given probabilities, and then answer this final question.